Hello, and welcome to the Tour of Hazards Around the World. Today, our tour is going to begin at Pasadena City College in California of the United States. Our next stop will be Timbuktu in Mali, West Africa. Timbuktu has an estimated population of 32,460 and is bordered by the Sahara, featuring a hot desert climate. Timbuktu was settled in the 5th century BC. However, like many other important medieval West African towns, settlements have been discovered near Timbuktu that predate the traditional foundation date. Thick layers of sand have thwarted archaeological excavations in Timbuktu, making it difficult to know its full history. One of the greatest atmospheric hazards of this region is aerosol optical thickness, otherwise called AOT. AOT refers to the measure of the extinction of the solar beam by dust and haze. Particles such as dust, smoke, or pollution scatter the sunlight, blocking it from the surface, which can lead to agricultural disruption. There is also what is called particulate matter, submicron particles of various species and composition which can travel to the lungs and cause a series of problems such as respiratory, cardiovascular, and skin diseases. The West Africa region shows higher levels of AOT due to its sudden stresses of industrialization in proximity to the Sahara Desert, which is known to be the world's primary source of dust aerosols. Efforts have been made to West African political leaders to promote change in factories to reduce emissions, which would in turn reduce the AOT. Our next destination is the capital city of Italy, Rome. The city has been a major human settlement founded in 753 BC and has a population of roughly 2,860,000. Rome is recognized for its mythology, being the birthplace of art, and having a rich history, shown in the architecture such as the Colosseum, built between 70 and 80 AD. Rome and the surrounding areas of Italy are also known for the lithospheric hazards known as earthquakes. Over the last 2,000 years, more than notably 400 destructive earthquakes have been documented in Italy, including the 6.2 magnitude quake that hit in August of 2016, resulting in 299 deaths and widespread destruction of cultural heritage. The Mediterranean region is seismically active due to the northward convergence of the African plate with respect to the Eurasian plate along a complex plate boundary. Whilst the density of seismic activity is still less than the circumference of the Pacific plate, also known as the Ring of Fire, this is still a considerable amount of activity found here. Seismologists have no way of predicting precisely when a large earthquake will strike. However, pursuing ongoing methods of restoration and material reinforcements to the architecture of Italy could help preserve its rich history against such frequent disasters. Our final stop is located on the Greek island of Samos. Located on the eastern Aegean Sea, just off the coast of western Turkey, Samos has a population of 33,814 and is known for its fertile vineyards and mild climate. Due to the same tectonic plate positioning as mentioned before with Rome, Samos has been known to be at great risk to the hydrospheric hazard tsunamis. Tsunamis are often likely to follow earthquakes and can cause huge damage to coastal cities. In 2020, a local earthquake measuring a magnitude of 7 was followed by a tsunami that measured 10 meters high. This hit Samos directly and led to rushing waters through the town measuring 1.8 meters deep. Luckily, no deaths were reported as a result of this tsunami. However, it was noted that local protocol for tsunamis is less efficient than those in regions with more common tsunamis, such as the Pacific or the Caribbean. Communities in the Mediterranean would benefit hugely from a more uniform method of alert or evacuation plan when earthquakes with a possibility of tsunamis to follow are reported. This concludes our hazardous tour around the world today. Thank you for following along, and stay safe out there.